All right. So this is going to be a bit different because I'm going to go do things out of order. I'm going to do chapter 6.3 first, and then we'll cover chapter 6.1, 6.2, 6.4, and 6.5. The reason being is because I don't like the order of things. They kind of jump you straight into matrices without really going through what a matrix is and what it can do. So in chapter 3, it looks at all that. So for me, it's just really weird how it's set up. That's my only complaint about this book is chapter 6. So notations for matrices. So we can represent a matrix two different ways. We can either use a capital letter such as A, B, or C to denote a matrix, which is what we're most likely going to be doing. So a matrix A and matrix B. A lowercase letter enclosed in a bracket, such as shown below, can also denote a matrix. Now, the way this works is, again, we can just say matrix A, or we can write it as this. The element, every individual number inside a matrix is called an element, and its position is noted by the numbers. The numbers down here. So, for example, A11 means first row, first column. Okay, A12 is first row, second column. A13 is first row, third column. So A32 is third row, second column. Okay. We can also represent a matrix by the number of rows and columns it has. For example, this is a 3 by 3 matrix. It's also called a square matrix because it has the same number of rows and columns. Okay. So, for example, what is the order of the matrix? The order of the matrix is a 3 by 3. Okay, so this is a 3 by 3 matrix because it has 3 rows, 3 columns. We needed to identify A23, so that's second row, third column. So 1 row, second row, third column, that's -3. And then A31 means third row, first column. So third row, first column, that is -3. So let me I set all this, so let me write it down so we can see it. Okay. So this is A3, and I did that again. This is a 3 by 3 matrix. Right? A23 is second row, third column, -3. And A31 is third row, first column, so also -3. And there we go. There's some information about a matrix. Right? Now, equality matrices. Matrices can only be equal, first, if they're the same order. Okay, so if this is a 2 by 2 matrix, this also has to be a 2 by 2 matrix. Also, they can only be equal if every individual element is equal. Okay, that means that X here, out here, X here is equal to 1. So X equals 1. Y plus 1 is equal to 5. Z, right here, is equal to 3. And 6 is equal to 6. All right, so that's the only way matrices can be equal, is if one, they're the same order. So this is a 2 by 2 matrix, and this is a 2 by 2 matrix. So 2 rows, 1, 2 rows, 2 columns, 1, 2 columns. All right, now adding and subtracting matrices. You can only add and subtract matrices if they're the same order. Okay, they have to be the same order because you have to be able to add and subtract every position. And it's really, really simple. Okay, so let's go ahead and we'll subtract the following two matrices. And I'm going to tell you it's much easier just to write it out as a subtraction problem. Okay, so this would equal just one big matrix. So this is a 2 by 2 and a 2 by 2. So I'm going to have 1, 2 rows, 2 columns. Right, and I'm going to take each position. So 3 minus 2. Right, -1 minus 1. You take each position minus its identical position. So first row, first column, first row, first column. Second row, first column, minus second row, first column. So 0 minus a -4. And yes, that becomes plus. And then 4 minus a 3. So you just subtract each position. And that's going to give you 1, -2, 4, and 1 as your answer. Okay? So, adding and subtracting matrices, super easy. Right? So, what is the zero matrix for all 2 by 3 matrices? A zero matrix, again, I think it's back up here, is where all the numbers are 0. So, basically, this is 2 rows, 3 columns, where everything is 0. So, 2 rows, 3 columns, where everything is 0. Okay? The additive inverse matrix, basically, if I add whatever I add to this, would make this a 0 matrix. 0, 0, 0. That's additive inverse. So what's the opposite of 3? -3. Opposite of -1? +1. Don't really need the plus. 0, 0, and 4, negative. That's our additive inverse matrix. All right. That. Scalar multiplication. All right. Easy, easy, easy. They want us to add these two together. They want to do 2a and 3b. Okay, so we need to do the scalar multiplication first. Now, the scalar multiplication means I'm going to take this number here, and I'm going to multiply everything in a by 2. So 2a would be 2 times -2, -4. 3 times 2, 6. 5 times 2, 10. -4 times 2, -8. Right? 3b means everything in b gets multiplied by 3. So times 3 times 3 times 3 times 3 gives you 18, -9, -3, and 0. And then they want us to add these together. So -4 plus 18, 14. 6 plus a -9 is -3. 10 plus a -3 is 7. And -8 plus 0 is negative. So the scalar multiple is just taking a constant times every position. All right, matrix multiplication. Now, this is where it gets complex, okay? In order, let's just get down to it, okay? Now, in order to multiply matrices, let's just take some notes here. Just a second. Sorry for the long pause. I had to hear my kids. I'll try to edit that. I don't know if I can, so we'll see. I might be able to edit. All right, so take some notes here. Number 1, you have to first check to see if you can even multiply matrices, because it may not even be possible to multiply matrices. Okay, so we have matrix A times matrix B. All right, the order of A, okay, let's just say we use is a 3 by 2, and the order of B is a 2 by 1. Now, these numbers here, basically the columns of the first matrix. So this is we have rows and columns, rows and columns. Right? The columns of the first matrix has to equal the rows of the second in order to multiply. So since these are equal, we can multiply. The new matrix, right? This is going to be a 3 by 1. You're going to take the outside parts, and that's going to give you your new matrix, a 3 by 1. Okay. Now, what if they don't match up? So what if you had an example 2 here, again, A times B, where A is a 3 by 2, and B is a 3 by 2 as well. They're both 3 by 2s. Okay. Well, this doesn't match. So, cannot multiply. And that's all you say. cannot multiply. And you're done. Okay, so if these don't match, you can't multiply. If they do match, your new matrix is the outside number. Okay, let's write down the order of these two. So this is a one row by 3 columns, and this is a 3 column by 1 row. So since these numbers match, we can multiply, and it happens to be my new matrix is a 1 by 1. So it's actually just going to be one number. Okay, and that's it. That'll be my new matrix. Now, the question is, how do we multiply them together? Okay. We multiply them by taking the row of the first matrix times the columns the second. So row times column. And we multiply the position. So first number in this row times the first number in that column. So -2 times -4. Okay. Second number times second number. 1 times 1. And then third number times third number. 3 times 2. So it's position times position. All right. Once we have that, we add them all together. So 8, 1, and 6 added up is 15. That is my new matrix. Just 15. Okay, we have another example on here. So let's do another one. I want to do something like this. Okay. So we know this is how many, 1, 2, 3, 4 rows and 1, 2 columns. Times, this is a 2 by 2 matrix, so 2 by 2. So since these match up, we're good. And my new matrix will be a 4 by 2. Okay? 4 by 2. I'm going to make a really big matrix here. So it's 4 rows, 1, 2, 3, 4, and 2 columns, so another 1, 2, 4. So 4 rows, 2 columns. And what I'm going to do is, again, this is the rows. So I'm going to circle the rows here. Let's do it in a different color because I can. Then I'm going to circle the columns. And next. So again, this is rows, this is columns. Column and column. Okay. So this is first row, first column. This, remember your notation. This is A 1 1, A 1 2, A 2 1, A 2 2, A 3 1, 3 2, 4 1, A 4 2. Okay. So here we go. We're going to take A11 first. So A11, that's going to be the first row times the first column. So I'm going to do position times position. So it's going to be -1 times 4. Okay. And it's going to be 2 times -2. 2 times -4 and -4, which add together gives you -8. That over here, -8. Right. Then we need a 2 1. Right. So that is, I'll do a 1 2. 1 2. We'll do one row at a time. So it's going to be still first row times second column. So first row, -1 times 0, -1, 0. 2 times negative 3. So first number in the row times first number in the column, second number in the row times second number in the column, times negative 3. Going to give you 0 plus a negative 6, which is negative 6. All right. I'm going to erase this so we have more room. All right. Then we do second row. So we do some blacks. So second row, a 2, 1. That's going to be second row, 0, 1 times first column, 4, negative 2. That's going to give you 0, negative 2. If you add together, negative 2. Okay. And then we have a 2, 2, which is second row again, 0 and 1 times second column, 0 and negative 3. Gives you 0 and negative 3. Okay. Then we have pink. Well, no, we'll just keep it in black. This is. Oh, let me undo that. I can undo. There we go. Okay. So, a 3, 1. So that's third row. Third. Second. First. Okay. So third row, 3 and negative 1 times first column, 4 and negative 2. 12 and 2, add together, 14. Okay. Then we have a 3, 2, which is third row, 3 and negative 1 times 0 and negative 3. That gives you 0 and 3. You add together, you get. All right. And then last row. So we have fourth row. Okay. So a 4, 1, that's going to be fourth row, 1, 2 times 4, negative 2, which is 4 and 4, add together, you get 0. Then a 4, 2, 1 and 2 times 0 and negative 3, 0 and negative 6, add together. So this is your matrix. This is your new matrix. 4 by 2, 4 rows, 2 columns, and there's your answer. That's how you multiply matrices together. All right. This applications, I'm not gonna worry about applications. Now, I showed you all that, and let me show you this right here because you're at home and you should have access to the internet. So what you can do is you can go online and you can just go to Google and look up matrix calculator. All right, the very first thing that comes up to me is this thing right here called matrixcalc.org. So what I'm going to do is I'm going to yeah. So we had a what was the question we had before? It was a dual screen this so we can see. All right, so we had the numbers -1, 2, 0, 1, 3, -1, and 1, 2. And matrix B is 4, 0, -2, -3. All right, and we want to do A times B. So matrix multiply. And there's the answer, which is the answer we just got. Okay, so yeah, you have the ability to go online and look at a matrix calculator. And here's the reason why. The calculators that I have in my room have a matrix function on it, and I would have you do this anyway. So feel free to use a matrix calculator to do most of this work, if not all of it. Try to do it by yourself, just a challenge if you really want to do it by yourself. But if you have a graphing calculator at home, you can do this on a graphing calculator, and even some scientific calculators. And I'll show you the one that I have here. Like, oh, it'll pop up in a second. All right. So it has a matrix section here, second matrix. So we can edit matrix. But the difference here is I can only do 3 by 3. That's the downside. Now that would be fine for most of the stuff we're going to do in the course, but like all the matrix multiplication and addition that's beyond a 3 by 3, like a 2 by 4 and stuff like that, it won't work. So that's the limit of those calculators. I do have graphing calculators in the room. I had enough for everybody, and that's what I was going to use. And you can do like a 10 by 10 matrix if you wanted on those things. Those aren't going to be much. That's why I'm perfectly fine with you this matrix calculator. And I just Googled it. Okay. Everything we need for chapter 6 is going to be on this, and it's going to make your life so much easier. So no one should have any problem doing the homework because this is going to do most of the work for you. Okay. Really, I just want to give you a brief review of matrices because I don't know if you've ever seen them before, and I want to make sure you have some identify or can be at least identify them and understand the concepts of them. But doing all the work, it's a lot of work and really difficult to do by hand. So I'm fine with you calculating. Anyway, I hope you have a good day. Stay safe. Wash your hands. Do your homework. Have fun.